Alright, again in this video I'm going to show how to find a CDF given a PDF, which I did in my previous video, but I'm going to add to that. Now I'm going to use the CDF to find a probability, okay? So a probability that x is between 0.8 and 1.2. Now, remember, definition of a CDF is the integral from negative infinity until you get to t of the PDF. Okay. All right, and so let's start with finding this one. I always think it's a great idea, especially if you are new to this, to start with a graph of your PDF. Okay, this could be a step that maybe you skip later once you become more advanced. But in the beginning, it's a very good idea to graph your PDF. So here's 0, here's 1, here's 2. Then we're going to need to go up to 1, probably going to need to go up a little bit more. So starting with this graph, I'm going to, we want to consider the values of the PDF for all the different possible x values. Okay, so from negative infinity until I reach 0, what is the value of the PDF? It's 0, right? It doesn't actually start taking x squared until x is more than 0. Okay, so let me go ahead and draw that. I'm going to draw this first interval in yellow. So from negative infinity until I reach 0. Okay, and I'm going to use an open circle there, because once x equals 0, then I'm going to be picked up by the next piece. So now let's do the next piece. X is now between 0 and 1. What is the value of f of x? It is x squared. So that's going to look like a little bit of a parabola, right? And actually I'll have an open circle there at 1. So let me go ahead and erase that and draw an open circle there at 1, 1, right? Because 1 squared is 1. And it's going to look like a little bit of a parabola, a little bit of a curved line there. And I'm gonna close in my circle because 0 squared is 0. Okay. So next I'm going to consider the interval between 1 and 2, right? And I take on x minus 5/6. So this is a linear line. I'm going to go ahead and use red for this. So when x is 1, 1 minus 5/6 is, let's see, like 1/6. So that'll be like somewhere around right here. Solid circle for that. And then 2 minus 5/6 will be, let's see, it's like 1 and a 6th, right? So it's a little bit more than 1. And now, actually, I'll have an open circle for that. Okay, so open circle for that. There we go. All right, and then from 2 onwards, I'm going to use yellow again. 2 onwards, I'm going to use a closed circle because I haven't covered 2 yet, so 2's got to be covered down here. Onwards, I'm going to be 0 again. Okay, so I want to find the CDF, means I want to find the area under the curve, under this f of x, no matter what value of x you give me. Okay, so you give me a value of x, I tell you the area under the curve. Later, I'm going to use that to find the area between 0.8 and 1.2. So let me go ahead and draw this. Where is 0.8? It's right here, somewhere around right there. And here is 1.2. So probability is the same thing as the area under a PDF. So I basically want to find the area under this. So there's a straight line there. My ultimate goal is to find this area here, right? And of course I could just do this integration between 0.8 and 1, and then 1 to 1.2, and I could find this probability, but I'm going to use the CDF to find this probability. So first thing I'm going to do is find the CDF. Okay, so that's the general area given any value of x. Okay, so starting with a value of x that is less than 0, I'm going to find the CDF from negative infinity to t of f of x when t is less than, strictly less than 0. Okay, so this is this yellow piece here. So maybe I should have used yellow. T is less than 0. Right? Remember, I'm just using t as a convenience variable, right? Really, it's the same thing as this x that you're seeing here. The only reason I'm using t is because later when you have t as your bounds, and it's also the variable that you're integrating against, it becomes somewhat confusing. Okay, so that's why we use t, but you can think of it as it's the same thing as x. Okay, so what is f of x when x is less than 0? When t is less than 0, it is 0. Okay, so this integral is 0. So f of t equals 0 when t is less than 0. Right? Okay, so the next piece is this green piece. So for the green piece, f of t, negative infinity to t, right, and of f of x dx. Okay, so now t is some number between 0 and 1. T is some number between 0 and 1, right? And you're having this equal sign here and no equal sign there. It's based off of the original PDF, right? So the equal sign in terms of when you're doing your integration, it doesn't matter. The equal sign doesn't matter when you're doing your integration. Later, it does matter when you are evaluating, for particular x values. You would get, if someone says, what is f of 1? Well, you would use this piece where x equals 1, not this piece up here, right? So, but when you're doing an integral, of course, the integral under a particular number is 0, so this equal sign is less important when you're doing the integral. But you want to keep it to match the same as your PDF. Okay, so your CDF should have the same bounds as your PDF. All right, so when I'm doing from negative infinity to t now is any number between 0 and 1. Okay, so it could be any of these values between 0 and 1. Later, I'll plug in 0.8, right? So I need to break this up into two pieces using the addition rule for integration, right? Because f is piecewise, I need to break this up. So I'll go from negative infinity to 0, then 0 to 1. Oh, sorry, not to 1, to whatever value t is. T doesn't necessarily need to go to 1, right? It can be any number between 0 and 1, right? So like I said, later we'll use 0.8. So 0 to any value, right, between 0 and 1 of f of x dx. All right, this piece is 0. This piece is x squared. All right, and so when you do this integral, you get 1/3 t cubed. All right, so f of t equals 1/3 t cubed when t is between 0 and 1. All right, so this is the first piece, and this is the second piece. All right, two more pieces. We need to do this red piece, and we need to do this final yellow piece. So for the red piece, now t is any number between 1 and 2. Okay, so f of t integral from negative infinity to t of f of x dx. Now t is some number between 1 and 2. And to get, if it's equal to, we need to look at the original. So equal for the 1 and not equal for the 0. Okay. Including 1, not including 2. Okay, so we need to consider all the different pieces of this integral using the addition rule for integration. We go to 0. Then we go from 0 to 1, right? Because we've covered If t is more than 1, we've covered all this green area, so we go from 0 to 1 now, okay, of f of x dx, and then we go from 1 to whatever value t is going to take, right? So later we're going to plug in 1.2, right? But it doesn't need to go to 2, it just goes to whatever value t takes. F of x dx. Okay, now just plug in all the different f's. This one is 0, this one is x squared dx, this one is x minus 5/6 dx. All right, go ahead and take these integrals. This one would come out to 1/3 x cubed evaluated from 0 to 1. This is 1/2 x squared minus 5/6 x evaluated from 1 to t. Okay, go ahead and do your bounds. Plus 1/2 t squared minus 5/6 t minus 1/2 minus 5/6. Okay, go ahead and write this in order and bring your like terms together. So we have plus 1/3 minus 1/2 plus 5/6. Get least common denominators to add those fractions. So let's see. This is, oops, that should be 1/2, right? Minus 1/2 plus 5/6, yeah. So this gets 6 on the bottom. This would be 2 over 6. This would be 3 over 6. This would be 5 over 6. Okay, so let's go ahead and write this out. Okay, so that's minus 1, that's plus 5, so it's 4 over 6, which is the same thing as 2 over 3. Okay, and so this is when t is between 1 and 2. All right. So lastly, we need to consider this last yellow piece when t is greater than or equal to 2, right? So lastly, we need to consider that piece when t is greater than or equal to 2. So I'm going to go ahead and write that over here. T is, what is f of t, negative infinity to t, f of x dx. Now t is greater than or equal to 2. So you go all through all the different pieces. 0 to 1, 1 to 2, lastly 2 to whatever value t is. Okay, so this first piece is 0, second piece is x squared, third piece 0 to 2 of x minus 5/6 dx, and the third piece or fourth piece is also 0. So 1/3 x to the third power evaluated from 0 to 1 plus 1/2 x squared minus 5/6 x evaluated from oops, that should say 1. Evaluated from 1 to 2. So 1 to 2. Okay, so this would be 1/3 plus 1/2 times 4 minus 5/6 times 2 minus 1/2 minus 5/6. Okay, if you plug this into your calculator or you solve it by using these common denominators, you should get 1. Okay, so when t is greater than or equal to 2, the value of f of t is 1, right? Which makes sense because the area under these curves, in order for this to be a PDF, the area under this green and this red one, it should be the total probability, which is 1. Okay. All right. So let me go ahead and write out my CDF. Last step. My CDF. Okay, remember I was using t to make it convenient for my integration, but I could call this x at this point again if I want to. Remember, it's the function that actually matters, what you plug into a function. The variable letter is less meaningful, okay? So, but make sure you're consistent. So if you have x there, then you should be making a piecewise function with regards to x. So x is less than 0. The next one was this 1/3 t cubed. Not t. Be careful. It's x if you have x here. Okay. So x cubed. Now x is between 0 and 1. Then 1/2 x squared minus, looking over here at this red piece, 5/6 x and 5/6x and then plus 2/3. And that was when x is between 1 and 2. Okay, include the 1, don't include the 2. And then lastly 1 when x is greater than or equal to 2. All right, so there's our CDF. Now, how do I use my CDF to find the probability that x is between 0.8 and 0.2? In other words, how do I use my CDF to find this purple area? Okay, so I'm going to go ahead and write that down. So let me write it using purple. So I want to find the probability that x is between 0.8 and 1.2. I'm going to use my CDF. Now remember, your CDF tells you the probability that you are strictly less than whatever number you give into it, right? So if I say, what is f of 1.2, it will tell me the area all the way behind 1.2, right? It'll give me all this area, which is too much, right? And how much too much is it? Well, I would need to subtract off the area of being less than 0.8, right? If I subtract these two, then I should get just this between area. I would get the area between, right? Which is this purple area that I want, right? So what I want to realize is that this probability is the same thing as the probability that x is less than 1.2 minus the probability that x is less than 0.8. Okay, and the probability x is less than 1.2 is exactly, by definition, what f of 1.2 is. And this is, by definition, what f of 0.8 is. Okay, so f of 1.2, let's think about this. So f of x, now I'm giving you 1.2, so x is 1.2. 1.2 is between 1 and 2, so I should be plugging this in here. Right? So I'll be plugging it in there. So this is 1/2 1.2 squared minus 5/6 1.2 plus 2/3. Okay, now I'm going to subtract off the probability that x is less than 0.8. Okay, I'm going to write this in red. So I'm plugging in 0.8 for x. So x is between 0 and 1, which means I should be using this piece of the function. So I'll be subtracting off 1/3 times 0.8, 1/3 times 0.8 cubed. Okay. At this point, you'd want to go ahead and plug that into your fraction, or plug that into your calculator. All right. If you plug that into your calculator, I get 0.1733. All right, and you should always make sure that whatever answer you get here, it should be between 0 and 1. If you're calculating a probability, then you should get a probability as an answer. And remember, probabilities must be between 0 and 1. So if you get a negative answer, not okay. If you get an answer that says 1.5, not okay. All right, you got to go back and see what happened. what happened wrong. Also, look at this 1.733 means that this area, or this probability, represents about 17% of the total area underneath of the curve. And if we go up here, you see it's relatively small, this purple area I drew in, relative to the total area underneath of this function. So yeah, it makes sense that my answer should be somewhere around 0.1733. If I'd gotten 0.9733, I would maybe question that based off of this drawing. So make sure that your answer makes sense. It's a good way to check that you're on the right track.